this, how do we leverage Azure Kubernetes Services and Dapper with designing and hosting these new architectures on Azure. With that, I'd like to introduce our service offerings. That is from Krish Services perspective, we are a Microsoft Gold partner and Azure DevOps, Gold application development and integration, and primarily focused on end-to-end services with the app development, app integration, and full end-to-end architecture guidance to all the way to managed services. Specialized in SharePoint, enterprise apps, and mobile apps, and also Power Platform. And we work very closely with Advizex, and I will have Joe Clark explain about Advizex Services here.
And hey, good morning, everyone. This is Joe Clark with Advizex. I'm our Director of Cloud Architecture. And Advizex has been a Microsoft partner since basically the instantiation of both companies, which is awesome. And a lot of our wheelhouse for helping folks is with identity, modern workplace, infrastructure projects, M&As, migrations, a lot of work along those lines. And definitely cloud infrastructure help as well, right? So it's kind of a hand-in-glove story here with Krish Services and Advizex working together to get really good outcomes for customers. Okay, and with that, I think I'll take it away. So the first part of what we're talking about today is really sort of the why. Why change an application architecture, and talk about how application architecture has changed. I think that's an important part of looking at the evolution of applications over, really the past 30 years. If we look at the 1980s and pre-1980s, right, largely this was monolithic in nature, where mainframe was effectively the computer, right? This was the only application architecture that existed at the time. And then we did see a move to, client server, right? Right about that, 1980s to the mid 2000s, right? We sort of saw this move to client server, where we saw network protocols get fairly well established. We saw a lot of different things from the application architecture just sort of evolving, right, into saying the personal computer being a thing instead of a terminal, right? And then in the late 2000s, really to move forward, right, we sort of see this evolution of saying, we have to find better ways of running the software in the same fashion over and over and over again. And cloud really was born out of that need, right, to be able to say we need to be able to build things faster, we need to be able to build things more consistently, and have more attempts at building software faster, and the freedom to fail without large investment. And that really is a large part of where cloud computing really came from. So evolution architectures, this is kind of where we see cloud computing and microservices going really hand in hand. So when we talk about monolith, I sort of mentioned that when we look at mainframe, right? It's really, when you think about how a user interacts with an application, a monolithic application architecture might be something where like you would have multiple instances of the application and services served by a single instance of the infrastructure. So a single server, a single point, a single piece of code to touch, right? Whereas in a microservices architecture, you've actually got basically modular portions of code that you can say, these are services that we run and host and can be called upon to do the thing that they were designed to do. And there is a little bit of difference in this when you examine, how those two can work together. And so if you think about who decided what that architecture really is, maybe a little pop quiz trivia. If you know what movie this is from The Matrix. This is the architect, right? The software architect is the person that's going to be the person that can decide how an application is going to be carved up and what kind of layout is going to be used, how services will be instantiated, what kind of data structures, what kind of access. All that's going to be done by software architects. So if you are building software, you have the luxury of saying, we can understand and decide what kind of architecture we are looking at having, right? If you are running software that was built for you, you have options typically to customize, but not typically a lot of change as far as to what core technologies are leveraged, right? If something is built on, .NET or Python or Java, those are kind of choices that are made early on, and those are very, very difficult, changes that, can be made, but a lot of times it's software architecture, right? What pieces are going to do what? So when we look at maintenance for a monolithic architecture, right, what does it take to really maintain the monolithic mainframe mentality mindset behind an application? Typically, it's a big event, whenever you go to update that, right? If you think about, updating many servers and having a patch weekend, right? There's lots of people involved. It's a highly visible event. There's a lot going on. Updates typically don't occur often, quarterly, maybe twice a year, right? Where you're seeing there's updates that happen then. More often than not, you need a maintenance window. Like, hey, there's going to be an outage. There's going to be a downtime. There's going to be a period of time where we are not able to access the application, and we need to be okay with that. And typically, every part of the application is touched during an update. It's like, all right, we're moving from .4 to .5, and look out, every feature we wrote in that major release is coming at you, whether you like it or not. And let's hope everything works and we don't have to roll back, right? Monolithic maintenance is kind of like getting your car worked on. It's like, we got to take it in for work. We got to get it on the skids. We got to get it out of, operation for a little bit of time to have it worked on in sort of a traditional fashion. So when we're talking about monolithic maintenance, this is effectively a large part of what this ends up looking like. And when we're maintaining a microservices architecture, it changes some of how we actually update components in the software that we're responsible for running. First and foremost, it really should not be a big event. We should be very comfortable with pushing small changes frequently in a microservices architecture, which gives developers freedom to build faster and build with more confidence that they can quickly roll back a small change. There's fewer teams involved. You don't need a massive team because there's typically distributed responsibility along with those distributed services. So smaller teams are required to be called upon for updates. Updates occur very often, right? Update, all the time, and push changes frequently. And then, sometimes there's a giant push to production lever, right? That sometimes people will say, hey, once a week, once a month, whatever. Like we would decide we're going to push, merge our branches together and push, code into production, and say, hey, we might have a gate or a lever that we would like to make a business decision on when to push to production, which is really good. Typically, one of the services is touched during an application update when we push things to production. So it's, it can be multiples, right? It can be multiple things together. But typically we're going to say, hey, if we update one thing at a time, that allows us to basically update and deliver value faster than, a quarterly or twice annually perspective. So maintaining a microservices architecture might look more like this than actually getting your car serviced, right? It is maintaining the car and running it while it's running down the road, right? So I'll let that loop through one more time because it's just too awesome, right? I mean, maintaining a microservices architecture is working on the car while it's running down the road, while you're gaining momentum, while you have users in the system and leveraging it, right? So really when you're looking at what this allows you to do is, this is obviously a terrible idea, and I do not recommend that you sit on a car while you're doing this, so maybe a bad example. But the idea as far as car maintenance is concerned is it's the same philosophy. People want to be able to use their car while they're building new features for it and have those features as fast as possible. And we really see that, maintaining and pushing new features into software, that's a giant part of being able to do that very quickly and on the fly. So does, moving to a modern application architecture solve all my worries? Not necessarily, right? There's giant code bases that exist today, and that can be a big project to move that, right? It's an architectural choice where you want to say, I want to have good deployability and good testability. I want to be able to make that choice myself. There's operational changes that come with moving to that. I mentioned, it's smaller teams, right? There's organizational responsibilities where if you're going to change an application architecture to microservices, you might get ready to say, hey, we need to change how we're structured from our people process and make that work. And you've got to own the application architecture. Again, like I said, if you're running someone else's built software, this is where you don't have that option to say, I'm going to dictate, the specific technology choices that you've made during the building of that particular application. Okay. So this is where it sort of leads to a culture clash, right? Where we have developers who love change, love new things, want to build, want to, have the latest things to be able to try to build with and build value for customers. And then you have infrastructure engineers who basically are saying, yeah, we like things that are dependable. We like things that have high uptime. We like things that necessarily don't move often, right? And so the little quip that I sometimes use is that developers want to play with the new toys, but never want to have to change the batteries, right? And that leads to infrastructure engineers basically saying like, hey, we've got we've got to make sure that if we're running infrastructure here, that it's kept up to date, that it's secure. There's a lot of things that we're concerned with that we maybe want to be more slow moving on. So there's a culture clash there, right? So I won't read through all of these, but there's definitely a lot of differences between a developer and someone that is responsible, for infrastructure on the back end, and saying that we're responsible for ensuring services continue to run, that we have stable platforms. And the one that I'll call out with, right, is basically, it's kind of summarized in the fifth, line item down here, which is comfortable taking risks, right? Developers are comfortable saying, this is a new tech, this is new, we're going to build it, we're going to run it, it's great. And infrastructure engineers are typically more risk averse, right? Like if it's a risky operation, we're not necessarily going to be gravitating towards that, right? Because it's different philosophies, right? It's almost like developers and operations are two different units, and combining them together really does start to say, like, hey, that really is what DevOps ends up boiling down to, is saying we want to build, we want to test, we want to release, deploy, operate, monitor, plan, and then have that feedback loop just be much, much tighter than a release a couple times a year. So really what does DevOps boil down to is it's increasing the value to customers, and it's respect for people, right? So when someone says, are you guys doing DevOps? This is what it boils down to, right? So the technologies are part of it, but it's really saying we want to increase value to customers faster. And what that means is, yes, oftentimes we need to do all the things we talked about: faster feature releases, better stability, more testing, all those good things. That's how we can increase value to the customers, by being able to be more frequent. And when we talk about cloud and how that comes about, this can be really, really difficult, because we're saying, okay, say for example we want to run this in a couple different environments and in a couple different clouds. It can be like saying, do we have anybody that knows all the cloud providers? Do we have anybody that knows AWS, Azure, Google, and like the number of services that exist in all of these different platforms is staggering, right? And there are just a bunch of different services that you can leverage in each of these cloud platforms, and some of them are similar and some of them are different in very nuanced ways. So to try to develop a code base against multiples of these and have that work well is certainly challenging, right? So how can I realistically deploy apps in multiple clouds, right, and build with speed? It's almost like we need something to abstract the application in a way that's native to cloud providers. Almost like it needs to be something portable, like maybe containers, maybe something that could contain that application, right? And so when we talk about containers, and that's really sort of the first thought here behind, building with container orchestration, is understanding what the container is. And this isn't a new problem. This is actually an old problem that's been solved through history a couple times before. If we look at cargo transport pre-1960, there was many different types of goods, and there were many different concerns, right? Like, I really don't want my coffee beans next to gasoline, and I'm concerned with what sort of things I might have. And from a transport perspective, they have a different concern, right? Their concern is that, hey, like, I want goods to be moved, right, to with different services. I've got a bunch of different types of things, right? So as they're looking at that, it's understanding that the matrix for support is very difficult. If I have a different thing to transport a car on a train versus a car on a boat versus a piano and a truck, it's very difficult to basically build a matrix for stability to say we need a solid handoff, right? So the solution there was the intermodal shipping container right around the 60s and 50s, right, where there was a couple different types of them, but this one that's basically the size of a semi really sort of took over as the standard, and makes up, to my understanding, about 70% of all the containers that exist today in the world. But the benefit here, right, is it standardizes and seals that until it reaches the final delivery, right, for the goods. And the benefit for the transport is that it's effectively loaded, stacked, transported efficiently across many different modes of transport. So they can bank on, hey, I know my hooks are here. I know I can drop it on this, this truck bed. I know that I can bank on this because it's a stability, right? And as we look at applications, it's actually very similar, right? A static website, a web front end service, an app service, an index, right? Message queues, middleware. those are all different across many different environments, right? Like a laptop versus a cluster that you run on-prem versus a cloud provider A, cloud provider B. The same problem, right, can end up being solved by the leveraging of containers, right? And saying we want to make that application portable so that we can run it in many different environments consistently on pretty much any hardware or cloud platform. So that's where we're saying, like, hey, if we can, solve that problem in the same fashion, where we are building software artifacts that are running in the exact same fashion across multiple different types of infrastructure, that gives us sort of that nice warm blanket of stability and comfort in saying, look, we know our artifacts are the same. So there might be some environmental changes, but we know for sure that the software we're building has certain inputs and certain services that need to be exposed, and we can be confident in that as we're moving forward and building. So containers are, basically a common tool that's used to build modern application architectures because of all these things that are listed here. They're portable, they're testable, they're deployable, and they're consistent. And those are a lot of the things that we end up seeing folks say, this is really what we want to have when we are looking to build software, right? The UI, the services, and this is not necessarily an easy battle or something that's that happens very, very quickly. But the why is extremely important behind this. Why are more enterprises embracing modern application architectures? Because like we said, it's just an architecture choice, right? You can do things in a monolithic fashion. You can do them broken out. You can make many different architecture choices. But why are many enterprises embracing this? Faster throughput. The developers can build faster when they're given the freedom to fail and the freedom to say, I want to have more iterative builds of my code. That's going to allow me for more time to do integration and unit testing, right? So to increase developer productivity, this is absolutely a way, right? So if, for example, you build software and every time you want to test it, there's a 3 to 4 hour process of standing up a bunch of VMs and load balancers and everything else and middleware and and caching, and you got to set all that up, and that takes like a couple hours to set up. That process of like building that is incredibly painful when it comes to developer productivity, right? So making sure that features can be built by removing every barrier to building successfully is a key attribute. Again, increasing value to the customers. It's a key tenet of DevOps. And when we talk about DevOps and saying increasing the value to the customers, that basically means building more useful features, getting more user stories solved and moved across the board, and bringing more value to those customers, right? And saying like, hey, what if we could bring this feature to market and that would just be amazing for our customers? And if that takes, a sprint planning that moves out, 2 to 3 years because of reasons, then, you're going to be slow moving as far as to the value you can bring. So how fast you can have on your time to market, very, very important as far as embracing modern application architectures. Operational efficiencies, right? I mean, so I think it's a fair thing to talk about when virtualization has pretty much become table stakes now in most organizations, right? So there's some sort of shared storage, there's some sort of virtual machines that are running in most locations, whether that's on-prem or whether that's in a cloud, right? And why is that? It's table stakes because of operational efficiencies. It's just much easier to have, a couple virtualization hosts that have maybe 50 to 80 VMs in them than to have racks and racks of servers 1-to-1 in a ratio with a bunch of different network drops and everything like that. It's just crazy to think about how that was how it used to be, right? If we go back to the, the Fresh Prince of Bel-Air slide, right? Like in the 90s, like, hey, you had a server that ran that, right? And one of the first jobs that I had, I was responsible for an SMS server back in the day. And I knew that server and I loved it and I hugged it, but it evolved away to